Let's talk about molecular formulas. Did you know that at its most basic level, the ratio of atoms in formaldehyde and acetic acid is the same? Chemists, like those in my favorite forensics TV shows, often use techniques such as combustion analysis and mass spectrometry to identify compounds. Let's assume that we are presented with two colorless unknown solutions. One contains formaldehyde and the other acetic acid. After combustion analysis, we determined that each of these unknowns contained 40% carbon, 6.6% hydrogen, and 53.3% oxygen. This means there are 40 grams of carbon, 6.6 grams hydrogen, and 53.3 grams of oxygen in our 100 gram sample. If I want to know the molecular formula for this, I need to know the number of carbon, hydrogen, and oxygen atoms, not their masses. Luckily, we know how to use the molar mass to convert from grams to moles. Let's do this. For carbon, this is 40 grams multiplied by 1 mole over 12.01 grams or 3.3 moles. For hydrogen, this is 6.6 grams multiplied by 1 mole over 1.01 grams or 6.53 moles. For oxygen, this is 53.3 grams multiplied by 1 mole over 16 grams or 3.33 moles. The molecular formula is related to the ratio of these different types of atoms. To get these ratios, let's divide by the smallest amount of moles, 3.33. For carbon, 3.33 divided by 3.33 gives 1 atom. For hydrogen, 6.53 divided by 3.33 gives 1.96. We can't have 0.96 of an atom, so we'll round this to 2. For oxygen, 3.33 divided by 3.33 is 1 oxygen atom. We now know the ratio of carbon to hydrogen to oxygen atoms in both samples is 1 to 2 to 1. That is the empirical formula, which gives the simplest whole number ratio of atoms, is CH2O. Our molecular formula can be any multiple of this CH2O, doubled, C2H4O2, or maybe even tripled, and so on. How can we tell which multiple we have? This is where mass spectroscopy comes in, because it can tell us the molar mass of the molecule. The empirical formula, CH2O, has a formula mass of 30 grams per mole. If the molecular formula is a multiple of the empirical formula, the molar mass will be a multiple of the formula mass. When our first unknown sample is run through the mass spectrophotometer, we find that we obtain a molar mass of 30 grams per mole. This is equal to the formula mass. So, the molecular formula is not a multiple of the empirical formula. It must be CH2O, which is the molecular formula of formaldehyde. Our first unknown is therefore formaldehyde. When our second unknown is run through the mass spectrophotometer, we obtain a mass of 60 grams per mole. This is twice our formula mass. The molecular formula is then the empirical formula multiplied by 2. This indicates that the molecular formula is twice the empirical formula, or C2H4O2. This corresponds to acetic acid. Good thing I could use chemistry to tell them apart. It would have been a terrible idea to use, smell, or taste these in notes. So now you know